My name is Kevin Moore. I'm a product manager at Google. I work on Flutter and Dart. I'm Kev Moo most places on the internet if you want to hunt me down on Twitter or GitHub, other places. Otherwise, you can go to my weird vanity domain, and that links to Mastodon and all the things. So I work on the Dart and Flutter teams. Who's familiar with Dart and Flutter? Who's actually coded stuff in Dart and Flutter? There's a few. That's great. Hopefully, after today, we'll have a few more. So let's start with Dart first. Dart is a client-optimized language designed to be fast and run on any platform. And there's the website if you want to learn more. For those that aren't familiar with Dart, let's do just a real quick introduction of some syntax and semantics. So there's hello world, pretty small. We have all the features you'd expect from a modern object-oriented language. So our syntax, if you do C++, Java, JavaScript, C#, it should look really familiar to you. Finals, private is just underscore, named arguments, getters, setters, the kind of things that you should be pretty familiar with. We have great support for async await. If you see here, I can generate a stream and mark it async, and I can do yield and just yield things out of a string asynchronously. We actually have a sync star keyword as well if you want to do a generator. And then if you look at the top, you see I can do await in a for statement and await over the streaming output. I can throw a lambda in to map and do some interesting stuff. So pretty familiar for folks that are used to kind of async await built into modern languages. And of course, generics as well. You see there's stream event. We also have sound null safety. And so this is actually just added in the last year. What I want to point out here is we have this value function at the bottom. You see that it returns int question mark, which means a nullable int. So depending on the value of my random Boolean at the bottom, I'll either return 5 or null. And what you'll see in Dart statically, not at compile time or runtime, but statically in your analysis is that this is illegal. Does anyone have a guess why this is illegal? Because invoking bit length val might be a null value, and so that's not good. So we could insert a bang operator in here, which basically is a null assertion operator, like I know this won't be null, but of course we still worry about having a runtime exception in this case. I can put in a check that says if it's null, throw a better exception perhaps. And what you'll notice is actually you'll get a hint now, which is this bang operator is now unnecessary. So we do really smart control flow analysis, and so we can prove statically that val cannot be null in this case because we've thrown an exception. And so to make the analyzer happy, we can remove the bang operator. So another thing I really want to point out is the soundness. So Dart's a little interesting, right? We didn't build on the JavaScript ecosystem like TypeScript. We didn't build on the Java ecosystem like Kotlin, which is tricky because we kind of have to bootstrap our own ecosystem. That's tough. But a benefit, at least I find in this case, is that because we have our own ecosystem, we can do things like this, which is we can optimize things like null safety end to end. And so we can actually have guaranteed runtime semantics and actually optimize our output code because we own the whole stack. And we can prove things in all the libraries because we own our whole stack there, which I think is pretty cool. Coming very soon, we have a records feature that will be coming, I guess, Google has an event coming up you might have heard of, so stay tuned. We're excited to be adding records to Dart and pattern matching, which is a feature I have never used, but I'm excited to start trying out. So this is coming in the next version of Dart. And Dart is not just for Flutter. So Flutter by far is our biggest use case, but I think it's important to point out that we are a general purpose language. So the Dart common front end, which I'll talk about in a little bit, this basically is the shared component that understands the Dart language. It's used by our runtimes, our analyzer, our formatter. These are all written in Dart. Our JavaScript compilers, we actually have 2 compilers, and our WASM compiler are all written in the Dart language. Our package site, pub.dev, which handles, I don't know how many zeros we have. I know we're in the hundreds of thousands. I think we're getting close to the millions of requests a day. Is all implemented in Dart and runs on Google Cloud. And then finally, we can do things like, I'm talking to a room full of folks that care about the cloud. So you can actually AOT compile a Dart library into a executable. You can make dart.exe and do something like deploy it in Docker. So our SDK download, the raw Docker image is maybe 600 megabytes because it has the JS compilers and the formatter and the analyzer and all those things that are great if you're doing development, but you really don't want to deploy. So you can create super tiny container on the order of about 10, I think 8 megabytes even, and deploy that. So we have a really good stack and a good story there for deployment. If you want to play with Dart, not now, wait till I'm done with my talk, but dartpad.dev is great. Of course, we run in the browser. It's a great place to get started with Dart and learn more. And of course, dart.dev. And so our favorite customer of the Dart toolkit is Flutter. Flutter is a UI toolkit for building beautiful, fast, productive, and open applications for any screen. And I really want to emphasize that, any screen. We have over 700,000 published apps in the App Store from companies like Nubank, BMW, Capital One. Toyota is using Flutter for their infotainment system in their cars right now. We're all over. So if you haven't heard of, you probably have Flutter running on your mobile device now and just don't know it. It's used all over the App Store. And at Google, we have dozens of teams that are building on Flutter across native, desktop, and web. So it's tricky to have, 2 or 3 pillars. We'd go for 5, which is a little ambitious, but I think it's good to kind of keep us on our toes. The first one is beautiful. You want you to be able to make applications that are gorgeous and kind of meet you where you are without constraints of native toolkits, with amazing and powerful animation system. We really want any developer to make applications that are really compelling to folks. Fast. We want no one to think that this is not a native toolkit. And in fact, generally, we talk about this a little bit. We've had a lot of success here, that we can get really good frame rates, consistently 60 FPS, iOS, Android, desktop, web, all the places. Really productive. It's actually really tough for me to talk about Flutter and not drill into this case. Those that have tried Flutter can attest to this. We have an amazingly productive developer cycle. You can actually load up your app on your emulator and then edit the code and hit save, and it'll just hot reload. So you could be 15 screens into your app with state, change the background color, change the margins, and it'll just hot reload, and you don't have to restart the emulator, do recompile. So this is a really powerful thing we have because we have access to Dart and the flexibility of having our own language. So this is a great feature of Flutter. If you do native app or any app development, try it out just for the productivity. Portable, we'll get into that in a bit. So embedded, RISC-V, all the places, web, desktop, we're designed to run everywhere, from web browsers to Toyota infotainment systems and cars. And open, 100% open source. There's always this discussion about Google that makes things and how's it going to go. You'll have access to Dart and Flutter forever. It's all open source on GitHub. I want to emphasize 2 things today in the context of web. The first thing is fast. This is not the official tagline, it's just my tagline I came up with, which is in general, you shouldn't have any clue that this is not a native experience on any platform. It's really fast. In fact, I invite people here watching online, check out the Wondrous app. It's a native app for mobile app for Android, iOS, just to see the type of fidelity, performance, beauty you can get from Flutter. And the second thing is portability. So Android, iOS for mobile, the web, desktop, Windows, Mac, and Linux. In fact, one of my favorite examples here, anyone run Ubuntu? Or at least heard of Ubuntu, right? The installer for Ubuntu is actually written in Flutter. And in fact, a number of native apps that ship with Ubuntu are now written in Flutter. So if you search for Ubuntu Flutter, you'll see their blog post about this. We're very excited to work with the Ubuntu team. They're leveraging Flutter for their application experiences. And embedded. We just announced recently that our RISC-V support is in preview and working well, and we're excited for people to play with that. I tried to find the image on the internet. There's someone who actually has Flutter running on a lanyard with some small batteries. It really runs everywhere. It's pretty cool. So I want to show an example of a native app, a desktop app in Flutter. Rive is a design app built for making interactive visualizations. So let's load up the desktop app. So I have my little teddy bear here. So this is 100% written in Flutter. There's a design experience. I don't want to mess it up because I have an animation I want to show you. But full 2D vector graphics editing here. There's an amazing animation experience that I want to show off. As you can imagine, making looping animations and interactive animations are actually a really tricky thing. So I can go into the tool here and hit play, and it's a state machine, if you see here in the bottom. So I can switch to maybe a hands-up experience, and you see we transition our state machine at the bottom, and our polar bear can be scared for a while, and then ceases to be scared. Maybe if I'm doing a game, I can have a success state that I can transition to, and then it transitions back. And of course, if we have an epic fail, he's quite sad. So this is an example of a desktop experience written in Flutter. So the question is, on the web, can we maintain this fast and portable promise, right? Can we have the same experience shipping on the web with high fidelity, with great frame rates? So this is where we started. We started with the classic kind of browser stack, JavaScript, HTML, and CSS. And so it's important to point this out. So big aspects of the Flutter engine, the entire Flutter framework, so all of our animation, all of the widgets you see, our implementation of the material spec from Google, the Cupertino widget set, which maps iOS, all of that is written in Dart. And then, of course, your application code is also written in Dart. And what we did was we compiled it all to JavaScript. We've been compiling Dart to JavaScript for 10 years now, effectively. And we use the DOM. So we use a combination of divs and canvas and SVG to kind of make things work. And it was OK. The performance was OK. The portability, the fidelity were OK. It turns out getting the DOM to dance the way we wanted is really tricky. The DOM wants to do its own layout, and it does it really well. But basically, we pay the cost of instantiating DOM elements, and then ask the DOM to not do any layout and let us handle layout is really tricky. So we switched our model, and this is actually the model we have kind of as of today for folks that are watching after March. We use a component called Skia. In this case, it's called Canvas Kit, which is a compilation of the Skia rendering engine. This is the rendering engine that's actually used inside of Chrome, all Chromium browsers. And it's the rendering engine we also use for Flutter native. So when we deploy to Android, iOS, desktop, Skia is the engine we use. At least today, there's some transition happening. So we take that engine and compile the C++ to WASM. And then the rest of the stack, web engine, that's the stuff that talks to the DOM, deals with browser APIs, eventing and things. The framework and the application code, we compile that to JavaScript. And so another question is that fast and portable? How'd we do? Well, let's go back to Rive. So this actually is not a native desktop app. This is a Chrome PWA. So this is actually a browser experience. In fact, I broke Rive a little bit to do this. They actually actively don't want you to use this. They actually found, because they now have they do have a native desktop offering. So if you play with Rive, please use their desktop offering. That's what they want you to use. There's actually confusion, because people thought they had the native app installed, and then they had the web PWA installed, and then they couldn't use file access the same way. There's still some stuff we're working on with the Chrome team and Fugo to have a really great native experience. So this experience has been on the web for years now, actually, and their native experience has been relatively recent. So you can make amazing desktop experiences with Flutter Web, and it works great using Canvas Kit and Skia. So I'd say we kind of nailed fast and portable. We have a number of companies externally, a bunch of teams internally using Flutter Web today for production apps. If anyone uses Family Link to manage their kids' devices, if anyone has kids using Google Classroom, these things all use Flutter on the web. But the question is, can we do better? And since we're at a WebAssembly conference, I'm sure you all could guess where I'm going with this. Can we take those bits now that we compile to JavaScript? Maybe we can compile those to WebAssembly. Now, I made my slides before Vivek offered to come speak at the conference. I'd recommend folks watching online to go watch Vivek's talk first about WebAssembly and GC. But that's kind of the interesting thing, right? Dart is a garbage collected language, like Java and many others. And so we need a garbage collection model. For a while, we did discuss taking our C++ virtual machine, compiling that to WebAssembly, and shipping that. And maybe we build it that way. But again, as Vivek mentioned earlier, this is not a good idea. One, it adds a lot of bloat to the download, because now you have to ship the whole Dart VM compiled to WebAssembly. Second, there's lots of performance implications, because especially when you're dealing with the browser, right? Because we're trying to interact with browser objects, call browser APIs. It's nice, the VA team and folks working on other browsers have done a spectacular job making really efficient garbage collection. It'd be great to leverage that. So I'm excited to point out again that WebAssembly is now, I think, stage 3 of 5, promoting the WebAssembly garbage collection standard, WASM-GC. Firefox and Safari are cranking on it hard, and hopefully if they find success, other browsers that I have not mentioned will hopefully also get on the train to support garbage collection. This aspect I actually find fascinating, and I think I'll get it right. Initially, I did have the language designer and the compiler implementer for Dart to WASM was going to join me, and unfortunately he's sick, so I hope Oscar's feeling better. But this aspect I find fascinating, like how do we get to GC from linear memory? So linear memory, we're aware, numbers. We add on reference types, which is great if you want to refer to things in the browser, right, from your WebAssembly code. On top of that, we add function references, the ability to actually pass a function around as a top-level, real-world thing. And the thing I found surprising is really GC spec is basically adding structs and arrays to that. That's about it. So how do you handle heaps, buckets of stuff and lists of stuff? And if you look at the spec, the notion of garbage collection is not mentioned anywhere. I guess garbage collection is left as an exercise to the reader. What this really does is gives you the ability to have all your memory discoverable and traversable, and then a garbage collector can do its work. So if you read the spec, don't be surprised if you see nothing mentioning garbage collection, because it's actually not in the spec. So how do we get the Dart language, which has been around for 10 years now, compiling to WASM? It's 5 easy steps. And again, I'm a product manager, so I have a pretty good understanding of how this works. Please be kind to me in the Q&A section, but I think we can walk through this. So the first is the common front end. This is actually used by all the Dart native runtimes, desktop, mobile, server, and our static analysis engine. I'm actually really surprised. I don't know how we take a thing that's sourced in Dart and run in the Dart VM. I would love to actually sit down with the engineers and ask. I'm still confused how they make that work, but they make that work. So this does the stuff that you expect, parsing, type checking, lowering of complex language features. So the idea is, we talked about switch statements before we're adding to Dart. That can get lowered to simple case statements or if statements, basically making things simpler. Next, we add type flow analysis. And so, again, this is something that's used by all the native compilers. Things like constant propagation. So if I have a constant string that embeds another constant string, figuring out the right way to condense those, to collapse those. Initial tree shaking. So we look at your main function, what's invoked. We don't include things that aren't invoked. Makes sense. And then a bunch of annotations that help out with later stages. Next is representations. And this basically turns in the Dart notion of a class, for instance, and turns this into a WebAssembly notion of a type. And there's some interesting things here. For instance, Dart, in some ways, has multiple inheritance. We have a concept called mix-ins, which allows you to take a class and effectively mix in other code. It's not quite multiple inheritance. We try to be careful. But we do have a concept of mix-ins. But in WASM-GC, it's basically a linear single inheritance model. So how do you figure that out? Box and unbox is very interesting. Again, everything in Dart is an object. So bool, int, double are object, reference objects. But obviously, if you're in a case where you're calling a function that takes object, you need to wrap that somehow as a reference object to pass into a function. But if I'm passing in an integer to a function that takes an integer, I don't want to box it. You just want to push on the stack. And so figuring out some of those things are things that can be done at this level. Finally, into code generation. And so we lowered a WASM. And what's great, actually, and Oski talked to me a bit about this, is that we don't need another representation. Like, WebAssembly is rich enough to emit to that we don't need some other kind of intermediate model. And so at this level, we think about how we call functions. Do we need a vtable? How do we handle dynamic invocation? We do support some motion of dynamic invocation in Dart, although we prefer you to have good typing. And precise types, which is something that we're going to work on soon. So the idea here is you might define a function that takes a map, for instance. But at this stage, we can actually figure out, OK, what kind of map? What's the actual concrete type? And then we maybe can get rid of dynamic invocation or a vtable, make things faster. And then more inlining, more optimization. And finally, we can call out to this great shared component, binarian, also called WASM-opt, that does a bunch of great things. Code elimination, you can read the list. So what's really interesting is, of those 5 boxes, only 2 of them are fundamentally new work. And everything else is stuff that we share. The top 4 bits are all written in Dart code. So if you're keen to have an object model and an API to write WASM-GC, you can go look at our SDK. It's all written in Dart code. You can generate WASM directly. And then we're super happy to have binarian as a shared resource. That we can stand on the shoulders of giants. Kotlin folks can leverage the benefits there, too, to have a great output model. So this is our plan for things as of March 2023, where we'll do a binding layer with Dart in our Skia code. We're calling this SQUASM. This is linear memory. And then built on top of that will be the app and framework code. And one cool thing, too, here is we eliminate the JavaScript interop layer. So it's WASM to WASM direct binding. So fast portable, hopefully even better. Like these silly things right now when we compile the JavaScript, we use the JavaScript numeric. So ints act like ints until about 53 bits. And then beyond 53, you start losing precision, right? Because it's effectively just a floating point. It's a double, right? So we actually real 64-bit integers. And there's other cases where we actually get better fidelity, better accuracy, better output because we target WebAssembly. It seems like even though this is, I'm one of maybe 2 or 3 talks talking about browser, I would be in a bad state if I didn't at least talk about Dart on the back end, Dart to WASM on the back end. We do run in cloud right now with containers. At the moment, because we're really optimizing for getting things done, testing end-to-ends, we're actually leaning on the JS embedder quite a bit. So things like regex, like instead of compiling our own regex engine to WebAssembly, we just use the browsers. Same thing for like double parsing, math, dates, even the event loop. Like the browser gives it to us, we might as well use it. So these things will have to figure out the story to be able to target a WASM runtime that doesn't have JS as well. There's some other interesting things too. Like when we compile Dart to JavaScript today, a Dart string is effectively a JS string. They're the same. This is not the case in WebAssembly, right? A JS string is no longer the same representation we have in the WebAssembly module, so we have to do some interop there and figure that out. And so we're doing a bunch of work around interop. The string ref proposal hopefully will help here, because obviously if you're talking to the web, there's just lots of APIs that are strings. Performance, we're super optimistic. It's funny that I didn't want to put perf numbers in my talk, but Vivek did. So we're seeing 1.52, some cases 3x. We have very limited benchmarking that doesn't do the full thing. We don't have that SQASM bit working yet. So all of our stuff that's working is actually going through a JS shim. So I don't want to quote perf numbers now, but we continue to be very optimistic, and hopefully we'll have data about perf very soon. But it's looking really good. So if you want to try it out today, you can. So you go into Chrome. You need at least Chrome 111. And there's 2 flags you need to enable today to try out WebAssembly written in Flutter. And in fact, we're working to get rid of the first one. So the JSPI we're using for our futures, hopefully we'll get rid of that. We'll implement a state machine. So you just need WASM-GC. And that's actually the one thing that will limit us from running in Firefox. So we're tracking. There's one bug in Firefox. Hopefully we'll get running. So let's see some demos. Goodbye, polar bear. So this is a Material 3 demo that we have. Material is Google's design language. So you can see it's a nice responsive application. The title bar goes to the bottom. I resize. The column comes out. I can do things like switch to dark mode. So like the animation effect, for instance, that's just built into the framework. And I want to emphasize, this isn't a browser. None of this is DOM. This is 100% in Canvas. Excuse me. But even in the Rive app, interaction, like you can do pinch to zoom on the animation or two-finger scroll, like it all works really well. So even in this case, let me see if I can find a pop-up here. And I can hit the escape key. Actually, wait, let's find, here we go, this is a better one. The escape key works, keyboard navigation. It's a full web experience. And this is all compiled Dart to WASM. What's really exciting is I didn't have to change the code. There's a little bit we're still working on launching URIs. But generally, I can compile the exact same application, JavaScript or WebAssembly, and it works. And what's great about that is, in the future, maybe we do still have browsers that don't support WASM-GC. The application developer can just build both. And then we'll do feature detection and load the right module. So maybe folks that have WASM-GC will have a better experience, but you can still continue to deploy applications, which we're excited about. We're actually in a model where we don't need WASM-GC. It's purely upside. The other thing I wanted to show really quick, I didn't get permission to show this, so hopefully I'm not ruining a surprise at I/O. But this is WASM-GC with Flutter and pixel shaders. So this is a Flutter application. This is a shader written in GSLA? I'm still learning. It's a fragment shader. But you can see that I'm using Flutter's input model to do hover effects, tracking state over here, sending color information to the shader to render the thing. You can build really kind of compelling experiences. And again, if this was full screen, you might never believe this is a web experience. So this is the type of fidelity, type of speed, type of performance that we're excited to offer people. And this works great in JavaScript today. Actually, most of the work here is being done by the shader. So what are our next steps? We are super focused on the browser scenarios right now. We want to get rid of JSPI so that we can run in Firefox. We want to get that SQASM layer together where we can bind linear memory WASM to JavaScript, to GC WASM so that there's no interop cost. That's really our focus. We are certainly excited about the server scenarios. We think they're really compelling. We have lots of people today running Dart on the server. So, discussions on component model and WASI, we're super excited about those. Kind of, for at least the next few quarters, we're probably not going to dig in there, but we're certainly excited about it. If you want to learn more about our work here, flutter.dev/WASM. As of today, folks at the conference, as of March 2023, you won't learn much more than what I've already discussed today. But the idea is if people stumble on this video in the future, hopefully that will have the current story. And again, you can find me on the internet, and I'm excited to answer questions. Thank you so much. Sir, it's always on the other side of the room, right?
Thank you. So in your demo, you're compiling Skia in C++ and essentially running that in WebAssembly in the browser. Did I understand that correctly?
Yes, which is hilarious because Chrome already has Skia in it.
That's my next question. So the Chrome-backed Skia obviously can take advantage of like WebGL resources, GPU, everything else that's on the system. So is that just a purely CPU-based code path?
No, we build on top of WebGL, and it's hardware accelerated. Absolutely.
Very cool. Have you looked into, especially for the 3D demo at the end, have you looked into WebGPU at all?
That is on our radar. Nothing to say today about it, but yeah, we're keeping an eye.
Fair enough. Thank you.
Any other questions? I flew all the way from Seattle. Really? Sir.
Can you talk to the bundle size difference between the JavaScript, HTML, CSS initial compilation target versus WebAssembly?
Great question. So as of today, it's always so fun on the web because you really need to talk about compressed size, right? Like everything goes over the web, Brotli or gzip. The material app I showed, which you can run today, if you search for material 3, you'll see the JS-compiled version. That's around 800K compressed JavaScript. And the equivalent that I built here using binarian WASM opt with all the flags is about 1.2 megs. So about 30% bigger. Two things to keep in mind there. One is we haven't started, no premature optimization. We all know that, right? So we haven't really started optimizing our code size. So hopefully conversations with the binarian team and just our own work will make that much better. And second, I think more interestingly, is startup time on WebAssembly is way better than JavaScript, just because there's less work to do to understand the payload. So it's a little bit of a race between your network card and your GPU, CPU. In some cases, we think that you'll have better startup performance with WebAssembly, even if the binary size over the wire is bigger, just because startup is much better. And certainly, we're optimistic you'll have much more consistent and much faster, again, optimistically, we start measuring, but your interactive performance will be better. Anyone else? I know I've talked to a few people about learning and trying out Flutter, so please, find me in the hallway. Over a break, I'm happy to sit down and do an introduction to Dart and Flutter. It's really cool technology, and we're excited to be joining the WebAssembly world. So thank you for your time.